Okay. Um, Hello, everyone. I hope everyone is enjoying the program so far. We're going to start session 5. We're so excited about having Dr. Gerard Melo with us today, and it's my great pleasure to introduce Dr. Melo. He's a professor at the Hasselbladner Institute for Digital Engineering and the University of Potsdam. He has published over 150 papers with many best paper awards like CIKM, ICGL, NACL, and as well as ACL Best Paper Award, ACL Best Paper Honorable Mention, and so many others. Previously, Dr. Demolo was a professor at Rutgers University in New Jersey and Tsinghua University in Beijing, and postdoctoral research scholar at UC Berkeley. Please join me in welcoming Dr. Gerard Demolo. Dr. Demolo, thank you so much for joining us today.
All right, thanks a lot for having me. Let me see, could you enable screen sharing? All right.
I think you need to be a host, right?
That's one option, yeah, sure.
Okay, can someone do that? Because I cannot see the option here.
Oh yeah, now I think it's fine. Okay,
perfect.
Let me share my slides. I hope you can all see them. So yeah, just one correction. I did not get a best paper award at NACL. That was a NACL workshop, just to be precise. All right, so yeah, the title of my talk is Appearances Matter, Enhancing the Presentation of Text Using Cross-Modal Representation Learning and Emotion Analysis. It's quite a long title. I've got a bunch of things in this talk that are all basically about combining appearances with representation learning and hoping to improve also the design process by doing that. So let me get started. Nowadays, we live actually in a pretty wonderful world. We have access to all of this information, and it's pretty comfortable to just go on your phone or ask your Alexa device for some piece of information, whereas I think for some of us here who are a bit older, we had to go back in the days, we had to go to the library to get certain kinds of information, or you had to know the right person. So we live in this wonderful world where so much text and other data is available to us. But at the same time, people complain about this precise fact that sometimes we have too much text. And when there's too much text, people call it a wall of text, and they tend not to read it. But in part, a reason they don't read it is, of course, also because of the way the text might be presented. If you look at this example here, very long lines, it's all capitalized letters. And so this talk is going to be about various ways to improve over this not very nice way of presenting text. And in particular about automated ways to improve the presentation of the text. And so there are going to be 3 major sections. The first is, I think, something many of you are familiar with, at least to some extent, font selection. And then the second part will be about affective text presentation, where we draw on emotion analysis to enable better selection of fonts and also colors and other aspects. And then finally, I'll talk about more cross-modal data understanding, cross-modal analysis, and using that to enrich text. So let's get started with the first part, which is font selection. So I think in this audience, it doesn't need too much motivation. Many of you are quite familiar with the importance of choosing fonts, but of course in our broader community, in the AI community, also in the NLP community, where you analyze text, you don't really care that much about how it is presented. All you care about is what is inside the text, what is the content and the structure, perhaps. And so it's a bit unusual to talk about the presentation of text, but I think in this audience, it's a bit more clear. Just to make sure we're on the same page. So some of the big tech companies are spending huge amounts of money to actually design new fonts. And so you might think, okay, if this makes sense for Google because they design user interfaces, Android and so on. So they need to really put in the effort to have a nice UI. But even other companies, Intel has its own font. So it's not just their logo, they have a whole font design based on certain ideas of what their corporate design should look like. And IBM has their font, and many other companies have designed entire fonts based on certain things they want to convey. And so and this is not just the tech community, this is the broader industry is doing this, because if you look at marketing studies and other kinds of studies from psychology, it is well known that the kinds of fonts you use may affect what people think about your company, about your brand, and also think about your products. So for example, there's this one study that shows that depending on which font you use, people will have different ideas about how credible your brand is, and also about how expensive the product is going to be. And another example is this picture here. This is from a recent study where they showed that the choice of font on product packaging not only affects whether people are likely to buy the product, it also affects what people expect how the product is going to taste. In this case, it's coffee. And so if you choose a certain kind of font, they're going to expect a different taste than for other fonts. And so we can look into some of the data that people found in some of these studies. One general trend is that round fonts that have more round shapes tend to be associated with sweetness, whereas angular fonts tend to be associated more with bitter, salty, sour taste. So any kind of edgy taste will be associated more with angular fonts. And so this is all quite interesting, but maybe only relevant if you're working in marketing departments. But even more generally, if you use the wrong font in your emails, then people might have very different expectations about what kind of a person you are. So people have done some studies where they rate certain attributes of the font, and then they also rate certain attributes of what the reader thinks about the sender of the email. And so if you use certain kinds of less serious fonts, they may think that you're probably a more supportive person, a very polite person, but they may also think that you're not very professional, you're not very assertive. And then there are other fonts that are associated with assertiveness, for example. And so you can have a lot of impact by choosing the right fonts in your regular correspondence, even in your slides. So I need to admit, I don't spend enough time on choosing the right fonts for my slides. Maybe I should, given all this data. Yeah, so these are important things that hopefully computers can help us with in the future. So how do we select fonts? Most of us, well, we just start using the default choice, or we scroll down the list of fonts and just basically select something that kind of looks like what we want. Some of us have a few favorite fonts and we just always use some of those. It's rare that we go through the whole list of fonts available on our system and try to make a perfect selection. And then more generally, it's even rarer that we go out on the web and see which other fonts are there that we could download and use for our particular use case. So there's a lot of need for automated assistance and better technology to help us search for fonts. And there are a bunch of websites out there that help us with this. These are aimed more at designers and And it's interesting that some of those websites claim to have over 100,000 fonts. And so basically this shows that the problem is not really manageable at a manual level. You need some sort of assistance to guide you towards the right font. So there's been some work on this, and of course, some of it has been done, a lot of it has been done at Adobe and other companies. One study we relied on was actually done by, co-authored by Aaron Hertzman, who was speaking earlier today. And so what they did was collect a bunch of data about fonts using crowdsourcing. So they gave some fonts to crowd workers and asked them to rate the font with respect to a bunch of different attributes. Overall, this data set gives us 200 fonts that are rated with respect to attributes such as playfulness, formal, how formal is it, how legible is it, and various other kinds of attributes, in total 37 attributes. So this data is quite nice, but it is limited to 200 fonts. And so in one of our works, what we wanted to do is apply it to a much larger data set of 2,000 fonts. And so nowadays, it's quite easy to collect larger sets of fonts on the web. And so we took a font collection. And one thing you can do is take every font and render a small little image based on just using that font. And now once you have an image for every font, then you can just plug it into a convolutional neural network. And what you get out of that, if you take some of the last layers, is a vector representation. And these sorts of vector representations basically already give you font similarity. So you don't even need to train on any font-specific data. You can use a regular pre-trained ImageNet model, and then it'll give you reasonable font similarity vectors. And so you have this visual representation space, which basically is just checking how similar are they visually. And now based on this, we brought in the crowdsourced data from that other study by Aaron Hertzman. And so using the combination of our visual representations and the small seed data set for 200 fonts that they collected, we were then able to make predictions of these attributes for all of the fonts. And so basically what we got were some nice results, a little bit better than the baseline method that they investigated. So basically using the CNN gives you quite a bit. And once we looked into it in more detail, basically we found that there are certain attributes that have a high potential for being represented by a font. So things like attractive, boring, dramatic, happy. These are things you can easily convey using a font. And then there are some that are more moderate. And then there are some that are not that easy to convey, at least not trivial to convey. You can, of course, do it, but it's a little bit harder to convey that something is bad using a font. All right, so here are some of the examples that we got. These are all fonts that were not in the original crowdsourced data and automatically chosen by our method. And so you can see the results are overall pretty reasonable. We get for each of these attributes some nice fonts, and we can quantify for any of the fonts how much they represent each attribute or reflect each attribute. Now, after we had done this, we saw we actually need to go a bit further, because this previous work had the set of 37 attributes, and it's quite nice, but it doesn't cover everything. So an interesting example is the Gillette logo. Gillette, as probably many of you know, is a company making shaving products. And so you can see in their logo that they have blades kind of represented in the letters, sharp edges. And so these sorts of things we might be able to discover by going to the attributes in the crowdsourced data. Maybe there's some attribute that reflects this sort of sharpness, this special edginess, but it's not so obvious. And more generally, there's this idea that a font can correspond with many different kinds of semantics. So there's some studies that, psychological studies, where they show people words written in a particular font. And if you look at these examples here, there are words like lovely, charming. Somehow something seems a bit suboptimal, a bit off. So you would think that maybe for words like lovely, charming, you would use a more cursive, less serious font. Whereas on the other side, for words such as stable, conformist, maybe there you would use a more formal font that's a more bland, neutral kind of font. And so this is actually from a study where they showed people fonts, words using fonts that didn't quite correspond to the semantics of the word. So for words such as lovely, you expect the opposite kind of font in this case. And so this is referred to as incongruency. Basically, congruency means that a font, the things associated with the font match the semantics of the word. And if that's not the case, then it's incongruent. And in these studies, they found people reacted slow to whatever task they were given when the font was rendered, when they used the font that wasn't congruent with the meaning of the word. So basically, this might even affect you at a very subconscious level without you even noticing it. And then more generally on the web, nowadays, there are all sorts of fonts. You can find fonts for basically any kind of idea you want to express. There are Halloween fonts. Here you can see like Monsters Inc. Monsters Incorporated font where there's an eye of a monster in the logo. And there are all these kinds of fonts that are very specialized. And so just having 37 attributes is not going to be enough. So what we did was we crawled a large scale, even larger scale font data set. This one had 10,000 fonts. And a nice thing about it is it also has user provided tags. Whoever uploaded the font or maybe also other users could add hashtags or tags to the fonts. And so we have some keywords associated with fonts. In total, 2,600 different tags and overall 54,000 font tag assignments. So here for this example, you have a tag such as Christmas, and then you have some other tags that are more descriptive, such as cute, playful, casual, warm, and so on. And so then we went ahead and again got our visual font embeddings using a deep model. We also added word embeddings, and then we came up with this way to use some approaches to align the two spaces, the word vector space and the visual font vector space. And so this gives us word vectors and font vectors living in the same vector space and allows us to do a bunch of neat things. Of course, the easiest thing you can do is just check for fonts that match any given word that you put in as input. And so these are some examples where we basically just tried to recreate the font tag assignments that were already in the data. And it works quite well, and it also finds new fonts that previously did not have that tag. And so with our method, we can show that although it didn't have the tag, we can still find the fonts given the search keyword. But of course, it gets even more interesting when you do vector arithmetic. So one thing we tried was taking a font vector and just adding a word vector to it. And this allows you to do queries such as, give me fonts like this input font, but more elegant than this input font. And so you can see it seems to kind of work. You get fonts that perhaps are a bit more elegant, or in the second example, you get a font that's similar to the input font, but a bit more playful. In the third example, you get a font that visually is quite similar, but leaves out some of the overly playful aspects of the font. So you get something that looks a bit more professional. And so this was actually something that was mentioned in a study with designers, that this is something they would often like to have. They have some particular font in mind, but they would like to modify it or make it a bit more formal, a bit more playful, things like this. All right, so this concludes the first part of the talk where I talked about font selection, and then the second part is about emotion analysis. And so one of the reasons for looking at emotions is that they are very fundamental to our human cognitive system. It's well known that the various ways in which the way our brain works is very much influenced by our emotions, and also it's very strongly related to perception. We immediately perceive emotions in other people's faces, and also in general, things that we see can change our mood. And so what we did was, now we looked at the data that we have and came up with a way to get the fonts for a few core affects, fear, joy, surprise, trust, and also just general negativity and positivity. And you can see these fonts do make a sense. We have, like for sadness, we get these very like bland, serene fonts. For joy, you have something more playful. For trust, you have something quite serious. So what we used was the seed data from the crowdsourced data set that was already pre-existing. And then we combined that with Word2Vec to derive these sorts of font assignments. And then having this now, we thought, okay, what if we now consult a general word emotion lexicon? So our existing data, which we derived, was a font emotion database. And now what if we put that together with a word emotion database? And by going via emotion, so via this emotional space, we can basically, for any kind of word, find some suitable fonts that best reflect the emotions associated with the word. So you can see here some examples. For a word like peaceful, you get something quite serene again. For a word like daughter as well, for guilty, you get a more serious kind of font. And so this was a nice resource called Fontlex. And we also evaluated it in a user study, basically got reasonable, quite good results. But one thing that bothered us a bit was looking at the examples. There wasn't enough diversity in the results. So because we're always going via the emotions, and the emotion lexicon we used was Emolex, the NRC emotion lexicon. And that basically just has binary labels. For every word, it tells you whether the word has the emotion or not. And also it's limited to 8 emotions. And so we started looking into how to expand on that. One idea was to go towards other emotion theories, like Plutchik's Wheel of Emotions. And that basically mandates, it provides a theory of how complex emotions derive from more basic ones. And so using that, we could derive optimism out of anticipation plus joy, anxiety out of anticipation plus fear, and so on. So we could get more complex emotions. We also tried looking at more fonts and looking at the font-lex entries for different words. And this gave us some nice results, but still we weren't quite happy with this. There's this whole debate in psychology, cognitive science about how to best represent emotions. And so maybe the dominant, perhaps the most dominant approach is to basically just to represent all emotions using two vector dimensions, valence and arousal. And so a lot of people believe that 2 dimensions is enough to represent the entire space of human emotions. And then there are other theories that mandate a set of basic emotions, like 8 basic emotions. And so there was this recent paper from Berkeley where they looked at data from video annotations, and basically their claim is, well, no matter how you do it, you can't decompose the data that we have into just 8 basic emotions. We need more basic emotions to fully account for the diversity of different emotions and how people use them. So we created a resource based on having much more fine-grained emotion distinctions. The idea is to have word vector representations where every dimension is now an interpretable dimension. It represents the particular emotion, and we have some of the very basic emotions, joy, sadness, fear, but we also have very fine-grained specific emotions like suspense or guilt. And overall, we actually have over 200 emotion labels included in affective. And so what we did was we used large-scale word vector representations, and we have a constraint algorithm. It's based on some of the counterfeiting vector modification ideas, and then it extends that to account for sentiment as well. And ultimately what we get is an emotion resource that we found corresponds much better to human judgments of emotions for words than much of the previous work. So previous work includes things like Emolex, and Depeche Mode is another well-known resource. It also outperforms some of the other simpler word-to-vec, naive ways of using word-to-vec. And so we were quite happy with this result. And it does not just cover these basic 4 emotions. It has in total over 200 emotion labels and reasonable vocabularies. And in the paper, we also have experiments on how you can then use it to do document level emotion prediction. And so this is the resource that you can download online at the URL given here, emotionlexicon.org. All right, another extension is extending this to the cross-lingual case. So in this Coling paper, we looked at low resource languages where we have very little data. And so there we created similar kinds of lexicons for over 300 languages. So the focus was not so much to get the highest possible accuracy, but to have at least something for some of the low resource languages. All right, and then we also looked into color. So in previous studies, it was found that color, of course, is very closely, highly associated with emotions. And so this is where we kind of brought this back together to our font work. We conducted a user study where we showed people different kinds of fonts and different kinds of colors. And the colors were taken from this previous study, so they had found good color palettes for each kind of emotion, but we wanted to see which works better or how well does it work in general. And so in our user study, we found that for certain kinds of attributes like seriousness, trustworthiness, disturbingness, fonts are the most important thing to choose, whereas for other kinds of emotions, calm, negative, playfulness, colors are more important than the fonts. But of course, we also previously saw fonts can be very playful. So the best way to do it is to combine fonts and colors. And so here's some examples. Here's a word cloud that is generated by our system that uses kind of positive color scheme and also a positive kind of font. And here are two more playful examples. These are movies visualized based on the emotions associated with them. One is a happy one, the other is, it's also a comedy, but it's supposed to be a scary comedy. So we have these more negative kinds of scary looking colors. And so the system can help users find the right colors and fonts. Okay, then finally in this last part, I'm going to be talking about cross-modal analysis and enrichment. So the first kind of enrichment is actually going to be about emojis. People think of emojis as a more fun kind of thing that you do, but it's also an important topic given how prominent emojis have become and how crucial they've become in our communication. There's the emoji movie, of course, but also when we want to understand social media, instant messaging, email subject lines, their emojis become very important. Nowadays, doing any sort of social media analytics without accounting for emojis would lose some of the nuance and some of the content understanding even. So there are many examples of how emojis have become very important. Word of the Year 2015 by Oxford Dictionaries and so on. So one thing we wanted to study is how do emojis relate to emotions? And naively, you might think that the word emoji, it does sound a bit like emotion, but there's no actual connection there. It's not an etymologically valid connection. Emoji actually just means a picture character in Japanese. And so it's just a coincidence that it happens to be so similar, but there are studies that show that the same parts of the brain are activated when you see an emoji as when you see a real face. And so this really shows how important emojis can be, and they really fill a gap when texting or when communicating by email. And so one study we did was just collecting a data set just to quantify how much are different kinds of emojis associated with different kinds of emotions. And so this is just a data set to collect such ratings. And then we did some experiments checking different kinds of models to automatically predict such ratings. So basically we can predict the emotions of emojis automatically, or for some of the popular ones, our data set already provides sufficient data. Another thing we looked at is creating word embeddings that are interpretable. And so previously we had affective, which was creating, giving every dimension an emotion label. And so in this other study, we gave every dimension an emoji label. So basically a word is represented as a sort of score, as a series of scores for each emoji. So a word like prank is, of course, typically a funny word. You would use this sort of happy emoji, but you might also be angry if someone pranks you. And so you have another score for that emoji, and then maybe you're sad that you got pranked, and so there's also some small value there. And so our emoji embeddings, we looked into them, and you can do a lot of data analytics with them. You can also plug them into a deep neural network and use that for interpretable emotion classification. And so we get pretty much similar results to using non-interpretable embeddings. And so that's about emojis. And then the other kind of enrichment that you can do, apart from adding emojis to documents automatically, is adding images to documents automatically. And so what we did here is look at the connection between images and the text. Nowadays on the web, pretty much every web page has not just text, but also images. And so given that images are an essential part of most web pages, most modern documents, even our research papers always have images in them. So it's quite important to understand what is the relationship between a particular image and the text. And so in one of our studies, we looked back at traditional discourse studies in NLP. And there people annotate using some scheme inventory of relation labels. They annotate how, for example, here, John can open build safe. He knows the combination. How does the second sentence relate to the first sentence? And in this case, according to one of the theories, it's an explanation. And so we adopted a similar scheme for cross-modal relationships, where we wanted to have people annotate what is the connection between the text and the images. And we defined an annotation scheme and crowdsourced data about this. And so in this case, it's an elaboration. This is also one of the traditional discourse labels used in discourse theory. And more generally, we also looked at some of the other collected data about some of the other aspects of the image-text relationship, such as which part of the text is most related to the image. And there are some interesting findings there. And basically, some parts are more typical to be in the text and not visualized, and other parts are typically visualized in the image. And in some cases, the image is quite important. In other cases, the image is just for illustration purposes. So ultimately what we want, one of the main applications, is to have automated image placement. You want to be able to come back from your excursion and you have hundreds of pictures, and you write a blog article about it, and the system should automatically pick some of the images and place them near the corresponding paragraphs where you talk about what is in the image. And similar things when you're blogging in general about general topics, you might have a library of images from the news or elsewhere. And so in this other paper there, we basically quantify, we optimize using an integer linear programming setup. We optimize this objective of maximizing the relatedness between the images and the paragraphs of text that they're associated with, subject to certain constraints. And along with this, you can plug in various kinds of image text relatedness measures. We've done a whole bunch of other kinds of studies where we develop new models. We have new transformer architectures for cross-modal alignment. We have certain kinds of GANs to generate captions from images, and then out of those captions regenerate an image and use that for adversarial training. We have contrastive losses, but ultimately some of the in this work, we found that actually you can outperform most computer vision techniques by just using web scale data. That's the most important thing you can do. If you have a large database of images, and even better if you have a web reverse image search engine, then you can collect tags using that and get much more fine-grained signals about what's in the image, such as this is the Grand Palace in Bangkok, or this is the floating market, and not just some abstract labels such as person, bowl, and so on. All right, so we have this image placement system, and then another application of these sorts of techniques is also to summarize news feeds. So this is not work done by us. This was related work done by Daniel Pietro at Bloomberg now. So they, at Bloomberg, they often present important business information to their clients. And so nowadays, most tweets come with images. And so they used similar kinds of approaches to ours to quantify which of these images are actually important. What is the relationship between the image and the text? Is it really crucial information? Is the actual information in the image? Sometimes you say, please see this amazing eagle or something, and then you have to show the eagle, otherwise the whole tweet doesn't make sense. Whereas in other cases, it's just some generic kind of image just for illustration purposes, just for aesthetic purposes, or to attract some attention. And so they found they could condense their Bloomberg terminal views by automatically deciding which images to keep and which ones to not show. And so that way you can pack more information in smaller screen real estate. So finally, the final part of my talk, just a few notes about going towards the user interfaces as the next level. So this last example already showed that user interfaces matter. And if we look at how people read, they used to read classic books, and nowadays we read things online on our screens. So a lot has changed. Most of the text we read, probably we read on our screens, and on our screens we have hyperlinks and so on. So coming back to what I was talking about at the beginning, where there's this whole wall of text idea, one way to improve it is, of course, to have more aesthetics, have paragraph breaks, have nice looking fonts, have colors, and so on. But another aspect also could be to just think about new ways to present information. The classic way is just to take a wall of text and summarize it. And automatic summarization is quite useful, but it has a bunch of problems. The summarizer may make mistakes, you lose some of the text structure, and basically you lose all of the formatting and the images. And so in addition to that, also different users may have different needs. And so we developed a system where basically you take a text and then it modifies the web. You take a web page and it modifies the web page to give you an interactive view. Basically, it's just highlighting the key phrases, the key sentences, and then as you navigate through the document, you can drill down on particular aspects and find, get a more fine-grained view of what people, what might be interesting to you. And so we did some user studies with that and found that students were able to answer reading comprehension questions faster by getting these sorts of guided displays instead of just a huge wall of text. And so in the future, people will be doing increasingly more graphical displays. We've also developed a system for turning a text into a graph. We're looking at ways to take structured data and condense it, or take structured data and present it visually. And then some other research is actually about taking all kinds of deep learning systems and making them explainable by having new kinds of user interfaces that have graph representations. So we've have some approaches where we make recommendation engines explainable, where we make dialogue systems explainable. And so these are also interesting lines of work. And so overall, the general idea is we should be having systems that take different kinds of data and merge them and repurpose them into something condensed that can be automatically composed into some nice final user interface, and have designs that are reflective of the content and also reflective of the user needs. All right, that concludes my talk. So I talked about a bunch of topics, talked a lot about font selection, seed-based approach, and the broad coverage web scale approach. I talked about emotions to help you choose fonts and colors, and also our affective database. I talked about cross-modal enrichment using based on emojis, images, and then some of these new user interface ideas. So that's it, and I'm happy to take questions now.
Thank you so much, Dr. De Melo. Thank you for the great talk. I think we can open this to QA if anyone have any question. Paul?
Hi, I have a question. Yes. So great talk. Thank you. So I was very curious at the end, especially with regard to the high text and some of the things similar to that. And I was wondering, how important is it to be right as opposed to just be varied? So for example, it seemed like the fact that high text just broke up the wall of text could explain a lot of making it more readable, even if the highlighting was essentially random. Has that looked into?
Yeah, definitely. Just breaking up text is an important idea. That's why we need to avoid overly long line lengths. Those are just basic user interface design issues. Don't have too long lines. And so just highlighting random parts would already help in that regard. But of course, making it more meaningful, which is not that hard to do, will get you even further. We didn't evaluate that as a baseline, just having random highlighting, but it would be interesting to see. And then beyond that, the more meaningful your highlighting is, the more you will, of course, help the user. And there, it doesn't need to be really accurate. As long as you're doing a reasonable job, it's good enough. Whereas in a summarizer, if you drop some important sentences and you only get the summary, you may not be able to understand the summary without going back to the original document. There may be some pronoun that you can't really make out what it refers to. And so we think this is a better paradigm where you come up with new ways to present text, or different ways to present text instead of just summarizing it.
Thank you.
As you have mentioned the user interfaces, I was wondering if the same techniques would be useful to modify the speech output in text-to-speech systems. So typically, I mean, meanwhile, these systems are able to imitate certain voices, but they're, for the most part, not really looking at the semantic or the meaning of the text. And I was wondering if you already have some technology that kind of goes beyond the meaning and looks at the effect of some words, if that could be also used within text-to-speech technologies in order to set the right accent, have the right voice framing, these kind of things to make the speech output more and more emotional and more affect driven.
Right. Yeah, that's an important topic. So when we think about typical text to speech, some of the traditional voices are very like bland, and that's basically the hallmark of traditional text speech, just being so recognizable as bland and monotonous. And so definitely adding some better intonation is an important topic there. And we haven't worked on this topic. We don't do speech much in our group, but there is a lot of work out there on getting intonation better, getting intonation right. And so some of the latest models, I think, are doing a better job there. They're not specifically looking directly at emotion or at affective signals. I think they're just learning from the training data how to pronounce certain phrases or vary their speed to pronounce certain noun phrases or other verb phrases in a more coherent way, and then emphasize certain key concepts. But it would be interesting to make that emulate human speech even better by recognizing the key ideas in a longer text. So going more towards semantics and using maybe some of the ideas from the talks we had earlier on emphasis selection, where you recognize what are really the important things you want to convey. And so I'm sure those could be used. Have to think about how to plug them into the models.
Yeah, sounds interesting.
Thank you, Tamar.
So yeah, thank you. Wonderful talk. I really enjoy learning about all the work you're doing in your group. I have a couple of questions. So one is related to the effect for fonts. I was wondering if anyone has noticed any differences related to the native script for the different languages, if that has different preference, if that creates different perceptions on the style in the font. And my second question is related to the part of images, trying to add images to documents. I was wondering if you're ever going to consider looking into the intent or the emotion, because we may have different images from the same location, the same place, but depending on what is your intent or purpose, you may choose one versus the other. Say, for example, you're reporting on some of the protests and you're left-leaning or right-leaning, and you're going to choose the images to present according to the view you want to portray. So anything you want to comment on that?
All right, yeah, very interesting questions. So the first question was about maybe cultural differences in the affect associated with fonts. And definitely that's a big issue. Also for colors, it's well known that there's some important differences there. So I think it was mentioned in the introduction that I actually spent 3 years as a faculty member at Tsinghua University in Beijing. So in China, we had, there are a lot of cultural differences. So certain colors like red that here we use for warnings and so on, there are supposed to be, are much more positive and don't have the same associations that you would have here. And then, or in Western culture, and then for fonts as well. So there, every day when I would go to work, there'd be a whole bunch of tourists taking pictures at the entrance of our university. And so you have there this sign that says basically the name of the university, Tsinghua University, and then it's written in a calligraphic script. And so to someone who is not an expert on calligraphy, it kind of looks a bit messy if you just look at it using Western eyes. It has strokes that are not very well ordered, but to an expert, they would see that it's actually very aesthetic and very formal. And so there are important differences there, and our data does not really reflect that directly. And so it would be interesting to study these differences for for fonts and also for colors as well. And then the second question was about the intent for when adding an image to a text. That's of course a very difficult question because first of all, you need to know what the intent of the user is in the first place. And so getting that out of the text is not that easy. And in our method, it's not really supported. But we are looking into, we just submitted a workshop paper on a new data set where we're trying to collect data that emphasizes some of the abstract associations that people have with images. So a certain image, if you just describe it using a regular model, it will say, okay, this is, there's, I don't know, there's a table and the forest or something. And then at an emotional level, however, you would say this is a beautiful sunrise, nice picnic or something. And so getting towards these higher level, a higher level understanding of what the image is conveying, that is something that's still a bit hard. But we're trying to make inroads on that, first of all, by just having some data sets and running some models, existing models on those kinds of data. That's as far as we have gotten, but I'm sure there's a lot more that could be done, and definitely that should affect what kind of image you choose, especially when you have a huge database of image to choose from. If you use a big repository of images you can pick for illustrative purposes, then you could use some of that. And there are also data sets that quantify the emotions conveyed by an image. So that's another thing you can use. We've also started doing some work on that.
Thank you. Do we have any other questions? Okay, I have one small question. So it's about the font representation or font word relationship that you described in FontFlex. So how do you think we can take into account the whole text representation, like consider the whole context when we talk about font? For example, the example you were showing about like the word lovely. So I was thinking like I can use this word with different fonts depending on the context that I'm using. So yeah, do you have any comments on that?
Yeah, so indeed, most of our studies were at a more individual level. We did some studies on word clouds where you have a whole bunch of words, but we didn't do that much work on selecting the right font for an entire text. But we do have ways to detect the emotions associated with an entire text, so you could use that. It kind of depends on what kind of user interaction you envision, because in many use cases, the human does not want to go too much in the direction of like changing to some very extreme font. Most users in many situations, they need something that's more neutral and maybe just in subtle ways going in a particular semantic direction. And so basically one of the sister of one of the authors who did a lot of this work is a designer. And so basically her idea was that we should mostly just try to guide humans instead of trying to mandate any particular decision. We should just provide suggestions and accept human suggestions. So the human designer should suggest that I want to convey these kinds of values or these kinds of ideas, concepts, and then the system would provide suggestions based on that instead of just trying to automatically guess based on the text what the user wants. So what the user actually wants may not even be in the text. It might be a value such as optimism or credibility, trustworthiness, and finding that from the text may not always be possible. The text might just be something technical about a product, whereas the values you want to convey might be something more abstract. But of course, you can try to work towards semantic understanding, except we haven't done any specific user studies on that.
Okay, thank you. Thank you very much.
I have another question.
Sure.
So I'm curious about sort of a follow-on to that is, maybe this is too subtle, but it seems like fonts could be used to convey things like tone of voice, sarcasm. You know, depending on how you say interesting, you can make it clear that you think something is not at all interesting. Wondering if you could use font selection to convey that sort of emotion.
Yeah, I think you could. We haven't done particular studies on that, but basically, if you have some incongruency with the literal message, then users have some sort of subtle hint that maybe you don't actually mean it the way you're stating it, and it makes it clearer. So if you say that's a great post, but you're not using a very positive font, you're using some, you probably have to make it quite clear by using a very extreme font that has quite notable attributes to make it really clear. But I think you could do that. How well it works remains to be seen. You might also have to add in use of color or use of other things. Of course, the easiest is to use an emoji, but just using the font, maybe you can help emphasize that it's sarcasm, but probably the text also needs to kind of hint at it, be expressed in a way that leaves it a bit ambiguous. So we haven't done detailed studies of that, but it would be interesting to see.
Thank you.
Okay, thank you so much, Dr. De Melo. I think we're right on time for the closing remarks.
All right, thank you.
Thank you.